Welcome dear students to my channel. So today we'll see the first exercise on circles. Okay, so in the last video we have understood the various theorems that will be useful in this particular chapter. Okay, so with the assumption that we have understood the earlier theorems, we'll begin today's class. So before we start today's lesson, so I would like to request you to give a like if you understand the sum. Alright, so let's begin with the sums for the day. Alright, so this is my first question. So question says, in the given figure, O is the center of the circle. Alright, angle OAB and OCB are 30 degree and 40 degree respectively. Find angle AOC. Show your steps of working. Alright, so this is your diagram given to you. So it is given that this is O, that is center, and the angle OAB is given to be 30 degree and OCB is given to be 40 degree. Alright, now you are asked to find angle AOC. Okay, so angle AOC has to be found out. Okay, so before I start solving this particular problem, let us try to analyze how to find this central angle. Okay, so if you compare this particular problem with the theorems we have learned, now one of the theorems says how much ever is this angle is going to be the double of this particular angle. Alright, so in order to understand this particular problem, so let's see what are the things given to us. So these are the things given to us, right? Okay, now let me join B and O. Okay, so I have joined BO, right? So that's why I have written join BO. Alright, now let's pay attention here. So we clearly see that OA, OB and OC, all of them will be equal because all of them are the radii of the circle. Okay, now with this, let us see how much is this angle going to be. Okay, so if I find this angle, then we know that this is going to be just double of that. Okay, so from this triangle, okay, so we see that this angle and this angle will be equal to each other because we know that these two are equal, right? So if these two are equal, then AOB is isosceles triangle. Okay, and if this is isosceles triangle, then this angle and this angle has to be equal, right? So that's why it is given that angle OBA, that is OBA is this angle, will be equals to angle OAB, which is equals to 30 degree. That means this angle is equal to how much? This is equals to 30 degree. Alright, now similarly this triangle is also isosceles triangle because this and this, that is OB and OC, are equal because they are radii of the circle. Now if these two are equal, then this is also isosceles triangle. That means this angle and this angle will be equal to each other. That is angle OBC, that is this angle, and angle OCB, that is this angle. They are going to be equal and they are going to be equal to 40 degree each. Alright, so this is 30 degree and this is 40 degree. So that means angle ABC will be 30 plus 40, right, which is 70 degree. Alright, now AOC is the angle subtended by the arc AC, right, and this is going to be the double of angle ABC using the first theorem which we have learned. Okay, so that's why angle AOC will be double the angle ABC, and angle ABC is 70 degree. So this means angle AOC will be 140 degree. So pause the video to note down. Question says, in the given figure, BAD is 65 degree, that is BAD. So this angle is given to be 65 degree. ABD is given to be 70 degree, that is this angle, and BDC, that is BDC, is given to be 45 degree. Alright, now you need to prove that AC is the diameter. Okay, so this is the diameter of the circle and we need to find angle ACB, that is ACB is this angle, right? So we need to find these two cases out here. Okay, so whenever we see a case where we need to prove that something is a diameter of the circle, then we will definitely go for the theorem which says angle in a semicircle will be 90 degree. Okay, that means if this is my diameter, then this angle is going to be 90 degree and this angle will also be 90 degree. Alright, that means if we are able to show that this is 90 degree or this is 90 degree, then we are sure that AC will be my diameter. So that's what we are going to do out here. Okay, now if you see here in this triangle ABD, then this is 65, this is 70. Now let us see how much is this angle going to be. Alright, so in triangle ABD, so this angle plus this angle plus this angle should be equals to 180 degree, right? So from here angle ADB will be equals to exactly 45 degree. Okay, so ADB means this angle, right? So from here to here is 45. Now this is also 45 and this is also 45. So total, that is angle ADC is going to be 90 degree, right? So ADC is going to be 90 degree. Now AC will be my diameter. As I said in the beginning, if I am able to show that this is 90 degree, then definitely this will be my diameter, because angle in a semicircle is 90 degree. Alright, so we have proved the first part. Now let us find the second part. Okay, so to find second part, we have angle ACB equals to angle ADB. Okay, so let us see where is angle ACB. ACB is this angle, right, which we need to find. And where is ADB? ADB is this angle, right? Now if I call this to be my segment, okay, so AB is forming this segment, and from AB two angles are drawn. One is this, that is ADB, and another is ACB, and we know that angles in the same segment will be equal to each other, right? So that means this angle and this angle will be equal to each other, and this will be equals to 45 degree. Okay, so we have found our angle ACB also. So pause the video to note down. Alright, so the third question for the day, given O is the center of the circle and angle AOB is 70 degree, that means this angle is given to be 70 degree. So we need to calculate the value of OCA, that is this angle, and OAC, that is this angle. Now if I call AB to be the arc, then the angle subtended by this arc will be AOB, right? And the angle subtended in the remaining side of the arc. Okay, so this is the arc, so remaining arc is this one, right? So I have chosen point C and I have joined with A and B. Alright, so this angle is going to be exactly half of this. So in other words, how much ever is this angle, this is going to be the double of this, right? So Q is the center of the circle and this is given to us, right? So as I said, arc AB subtends angle AOB at the center, and OCA means this angle at the remaining part of the circle, right? So that's why AOB will be double of this, right? Okay, now in other words, we say OCA is half of AOB, right? Now how much is AOB? AOB is 70 degree, and half into 70 is how much? It is 35 degree. That means my angle OCA is how much? 35 degree. Alright, now for the second case, that is OAC, let us see this blue colored triangle. Now we know that these two are the radii, right? So that's why they will be equal to each other. Now if these two sides are equal, then definitely this will be isosceles triangle. That means this angle and this angle will be equal in this case. Alright, so that's why OAC and OCA, that is these two angles are equal, and this will be equal to 35 degree, which we have already found out. So pause the video to note down. Okay, so in this case it is given that O is the center of this circle. Let us see the first diagram. So this is my first diagram, right? So in this diagram, this is my A and this is my B. Alright, and we need to find the value of A and B here. Okay, now let us see how to do this. Now if you see here carefully, this AB is the arc and this subtends angle AOB at the center. Okay, and in the remaining part of the circle, arc AB subtends angle ACB. Alright, that means this angle will be the half of this, right? So that's what is written out here. Alright, so that's why AOB will be equals to double of ACB. So in other words, ACB will be half of AOB, right? And how much is AOB? AOB is 130 degree, right? So half of 130 degree will be 65 degree. That means ACB we have found, right? Angle ACB is how much? It is B. So that's why the value of B will be 65 degree out here. Alright, so we have found it, the value of B. Now let us move on to the next case. Now in next case, we have learned one of the theorem which says about cyclic quadrilateral. Now can we see some cyclic quadrilateral here? Yes, we are able to see this to be my cyclic quadrilateral, as all the vertices are lying exactly on the circumference. Alright, now we know that the opposite angles will be supplementary, or the sum of the opposite angles of a cyclic quadrilateral is 180 degree. That means this and this are lying exactly opposite to each other. So that's why we have A plus B equals to 180 degree out here. So we know the value of B, which is 65 degree, right? So that's why my value for A turns out to be 180 minus B, that is 65, which is 115. So we have found the value of B and A, right? Now let us find the value of C from the next diagram. So this is the diagram given here. All right, so we need to find the value of C out here. Okay, now if you see carefully here, if I call this to be my arc, okay, if I call this to be my arc, then the angle subtended by this arc with the center will be this angle, right, which is greater than 180 degree. So this is also known as reflex angle AOB. Okay, reflex angle AOB. Now in the remaining side, or the remaining part, that is this part, see, this is the arc and the remaining part is this one. Okay, and the angle made by arc AB in the remaining side is angle C, isn't it, right? So that means this C will be exactly half of this reflex angle. Hope you are understanding this. Okay, so angle subtended at the center will be double this angle, right? So that's what is the theorem. So that's why reflex angle AOB, that is this angle, will be double the angle ACB, which is C. Okay, now we can write ACB will be equals to half of angle reflex angle AOB, right? So let us see what is the value of reflex angle. Now we know that this is 112, that means this will be equals to 360 minus 112, which is 248. So half of 248 is 124. So that's why the value of C will be 124 here. So pause the video to note down. Okay, now let us move on to the fifth question, and this is also going to be a similar kind of question. Okay, so here also we need to find the value of A, B, C and D. Now in this case there are 4 different diagrams given to you. So the first diagram is given to be this one. Alright, so we need to calculate the value of A here. Okay, so O is the center, that means BD will be my diameter. Okay, so let us see how to do this particular question. Now we see that this AB is the segment, right? So the angle formed by this segment are this angle and this angle. So that means if you are able to find this angle, then we are done, because this angle and this angle both are going to be equal to each other. Fine. So BOD is the diameter, we know that, right? So that's why BAD will be 90 degree, because angle in a semicircle will be 90 degree. So this angle BAD will be 90 degree. Alright, so this is 90 degree and this is 35 degree. So we will be able to find how much is this angle also. Okay, so we know that this ADB will be equals to how much? 180 minus this angle, that is this much. So angle ADB is turning out to be 55 degree here. Alright, so if this is my 55 degree, then definitely this also has to be 55 degree, because they are angles in the same segment. So that's why the value of A is 55 degree out here. Now let us move on to the next diagram. Okay, so in the next diagram we need to calculate what is the value of B. Okay, so in this case this AB acts like my segment. Okay, so if this is my segment, then this angle and this angle will be equal because they are angles in the same segment. All right, so let us try to find this angle so that we will be able to find this. Now we know one of the theorem which we have learned in our junior class, which says the exterior angle will be equals to sum of the opposite interior angles, right? So in this case, if I take this to be, okay, so I have not written here, this is my E. Okay, so this point is going to be my point E. Okay, so that is point of intersection of AC and BD is E. All right, so this angle, that is BEA, is equal to sum of this angle and this angle. All right, so with this we'll find angle C. So in angle EBC, triangle EBC, so EBC, so we are talking about this. So we know that exterior angle will be sum of the opposite interior angles. Okay, so exterior angle is 120 degree. Okay, so this is the triangle EBC and this will be my exterior angle, and this will be equals to this angle plus this angle. Okay, so BCE CE plus 25 degree. All right, so from here, what is BC? So BC is turning out to be 120. This goes over there, becomes minus 25, which is 95. That means this angle is 95 degree, right? So as I said, this angle and this angle, they are going to be equal because they are angles in the same segment. All right, that is angle B is 95 degree. Okay, so that is the value of B is 95 degree. So pause the video to note down. Now let us move on to the next diagram, that is this one. Here we need to calculate the value of C here. All right, so let's calculate the value of C. Now it is clearly seen from the figure that this AB, arc AB subtends angle AOB at the center and ACB in the remaining part of the circle, right? So that's what is written out here. So that means this angle AOB will be double of angle ACB, which is going to be, if this is my 50, then this is going to be obviously the double, that is 100. All right, now let us see this triangle AOB. Now AO and OB both are radii, right? So radii of the same circle. That means this triangle is isosceles triangle with this angle equals to this angle. Okay, that is angle AOB will be equals to angle OBC, right? Okay, now in this triangle, if I add all the angles, this is going to be 180 degree, right? So this angle is already 100 degree. So that means this and this will be 180 minus 100, right? So that's why OAB plus OB is 180 minus 100, which is 80 degree. All right, now let us see, as I said, this angle and this angle both are going to be equal, same, right? So that's why I have written, instead of OBA, I have written OAB. So OAB plus OAB will be 2OAB. Okay, so from here we know that C, okay, so OAB will be 80 by 2, which is 40, right? And we know that angle OAB is angle C, so that's why C will be equals to angle OAB, which is 40 degree. That means the value of C is 40 degree. Okay, so let us move on to the last, that is this part. Okay, now in this case we are asked to find the value of D, right? Now in this case we see that this PB, if I call this to be my segment, then this angle and this angle, they are going to be equal. So my aim is going to be to find this angle so that I will be able to find the value of D. All right, now one more thing we can see here is this is my diameter. All right, so that means this will be my 90 degree because angle in a semicircle is always 90 degree. Okay, so as I said, APB will be 90 degree because it is the angle in a semicircle. All right, now we see that if this is 90 degree, then this plus this in this triangle, this and this is going to be 90. Okay, because 90 plus 90 gives me 180 degree. So that's why PAB plus PBA is given to be 90 degree. Now one more thing is given, that is PBA is given to be 45 degree. Okay, so instead of PBA I have written 45. So that means what is the value of PAB? So PAB will be also 45 degree here. So this is also 45 degree. Now we have found this angle, means definitely we are able to find this angle as well, right? So we know that PAB will be equals to PCB. This is not PQ, this is PCB. Please make the correction. So angle PCB, because they are angle in the same segment, that is angle PCB will be equals to 45. So this is 45, so that's why this also has to be 45. So that's why the value for D will be 45 degree. Okay, so you may pause the video to note down. So with this we close for today's session, and in this particular exercise you will find many problems. Okay, so this is going to be a kind of boring chapter for you, but we'll try to do it slowly, steadily. Okay, so we'll do only this much for today. As I said, if you like the video, please give a like button. Okay, so with this we close for the day. Thank you very much.